Hi there, everyone. In this video, we are going to talk about how to simplify fractions and find equivalent fractions, as well as how to model fractions using different models. So the problems are going to show us some rectangular models and some circular models, and we're going to figure out what fractions they're representing. This video is going to correspond directly to day 5, week number 2 of your e-learning packets. So go ahead and open it up and we will get started. Okay, so this right here is the first page we're going to look at. The instructions are to match the fractions. So we're going to look at the problems or the fractions on the left-hand side here and find equivalent fractions for them on the right-hand side. So they've already told us that 1/3 matches 12/36, because if you take 1/3 times 12/12, it equals 12/36. Okay, so go ahead and take a line on your paper from 1/3 to 12/36. All right, because they already gave you that answer. And we're going to go ahead and look at 5/6. Now, if you see 5/6, the numerator is smaller than the denominator. It is a regular fraction, right? So when we look for an equivalent fraction over here, we're looking for another fraction where the numerator is smaller than the denominator. That is because the value of both fractions should be less than 1 whole. What I mean is 15/3 here, the value of that fraction is greater than 1 whole because your numerator is bigger than your denominator. Okay, 15/3, if we were to simplify that, would be the same as writing 5. All right, but it doesn't look like that's the one that they chose here, so you might have to multiply it to find another equivalent fraction, because to find equivalent fractions, you can either simplify and go smaller, or you can multiply and get bigger numbers that still have the same value. Okay? So keep that in mind when you are matching your fractions here. If the numerator is smaller than the denominator on your left one, the numerator needs to be smaller than the denominator on the right number. Okay, so we're going to take a look at 5/6. So using that method, I'm going to go over here to the right and see, is my numerator smaller than my denominator? Nope. Can't be 45/9. Nope. Can't be 24/9. Nope. Can't be 17/2. So I'm going to take a look at 25/30 because the numerator is smaller than the denominator. It looks like it could be a real possibility for an equivalent fraction. My next step is to see, can my denominator evenly divide into this denominator? Well, 6 does fit into 30, right? How many times does it fit into 30? 5, right? So what I'm going to do is I'm going to take 5/5 and multiply it by 5/6. And if I get 25/30, then I know they're equivalent. I know they're a match. Okay, so 5/6 times 5/5. I know the 6 times 5 is 30, so my denominator is 30. 5 times 5 does give me 25. So 5/6 is going to be an equivalent fraction for 25/30. Now, if you want to do the work for this page on another paper or off to the side here, that is totally okay with me. For now, I'm going to clear my work so that I can draw that line showing that they are matching. Okay, so 5/6 matches up to 25/30. Okay, so that is how you're going to do the problems on this page. Now let's go ahead and look at some fraction models. Okay, so we're going to look at the second day 5 page that says, write the fraction that's represented by the image, then write the fraction in simplest form. So we have 2 steps here. We got to first find the fraction, then we got to simplify it. In order to find the fraction, we have to start by counting how many total parts there are in our model. So how many parts is this big rectangle divided into? Okay, that would be 1, 2, 3, 4, 5, 6, 7, 8. Okay, so that's going to be my denominator. The total number of parts is my denominator. For this problem down here, the total number of parts would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay? You're counting the total number of rectangles, small rectangles or parts within this big rectangular model. Okay? Now to find the numerator, we have to look for how many of the rectangles are shaded. How many parts did they shade in here? Okay, so in this one, they shaded 1, 2, 3, 4. So my fraction then is going to be 4/8 because 4 out of the 8 parts in this model are shaded in. But we're not done yet because there's another instruction here, and that is to simplify. So I'm going to see, do these two numbers have anything in common that they can be divided by? The answer is yes. They are both even numbers, so they can both be divided by 2. Okay, so I'm going to take 4/8 divided by 2/2. 4 divided by 2 is 2. 8 divided by 2 is 4. Can they be divided again? Yes, they can be divided by 2 again. So when we divide them by 2 again, that gives us 1/2. Okay, if straight from the start you say, hey, Miss Renneker, I noticed that 4 goes into both 4 and 8. Why can't we just divide by 4? You can, and that will save you the extra step. Okay, so if straight from the start you want to divide both the top and the bottom by 4/4 and get straight to 1/2, you can do that as well, and that would be totally correct. Okay, so that is how you're going to do the problems on that page, sorry. Now we're going to look at the second page of day number 5. Okay, so there's kind of a pattern with these problems here. They're circular models. Each color represents a different fraction. So if I was you, I would start by making myself a little key telling me what each color represents. Okay, so if we look at our problems here, we see this entire circle is shaded in red. So that tells me that red equals 1 whole. Okay, so red is equal to 1, or 1 whole. The pink here shades in half the circle. Okay, so pink in all of these problems is going to be 1/2. Okay, the yellow looks like it makes up for 1/4, right? 1, 2, 3, 4. So I'm going to put down that yellow is equal to 1/4. The blue looks like it is equal to 1/8, because if we look down here at our problem, there's 1, 2, 3, 4, 5, 6, 7, 8 pieces that the blue fits into. Okay? So it's going to be blue 1/8, and that leaves us with the gray. Okay, so the problem in particular that helped me figure out the value of the gray was this one right here. Okay, 1, 2, 3. Those 3 make up for 1/4 of it. So 3, 6, 9, 12. Okay, the gray is worth 1/12 of the circle. Okay, so gray is going to be 1/12. So now that we've figured out how much each color is worth, we're going to go ahead and add them together to find what each fraction is. So for this fraction right here, they're having us add a pink 1/2 plus 3 gray 1/12. Okay, so the way that we would write that is 1/2 plus 3/12. Okay, so as we have talked about several times, when we add fractions, you need to have a common denominator. You cannot add if your denominators are not the same. In order to do that, I gotta make this denominator common with this one. I know that 2 can evenly divide into 12, so I'm just gonna go ahead and make my denominator 12ths. So, in order to make it 12ths, I have to take 1/2 times 6/6, because I know that 2 times 12, or 2 times 6 will give me 12. Okay, so we do the top times 6 and the bottom times 6. 1 times 6 gives me 6. 2 times 6 gives me 12. So I'm going to take 6/12 plus 3/12. When I add fractions, the denominator stays the same. So it's going to be over 12ths. But 6 plus 3 is 9. Right? It tells me, though, that I need to write the fraction in simplest form. In order to do that, I have to see, are there any numbers that both my top and bottom number can be evenly divided by? Okay, I know that 3 evenly fits into both 9 and 12. So I'm going to go ahead and divide both of them by 3. Okay, so I'm going to divide my top and bottom by 3, which I'm going to write my answer up here because I'm running out of room. 9 divided by 3 is 3. 12 divided by 3 is 4. Which, if we look back at our model here, 3/4 of this circle are shaded in, so it makes sense with my answer. My answer is 3/4. Okay. I hope that helped you understand how to solve these problems. If you have any more questions, please don't hesitate to reach out to me. But in the meantime, have a great day.